Okay, now proceeding ahead with the combinations, we have today's session that properties. It's okay, it's absolutely fine. Achaya, not an issue. Okay, now we have the next part, that is the combinations. So in the combinations, instead of putting the lecture over combinations, I have taken the lecture of properties of combinations first, and then we have the lecture of combinations. This is because for JEE, solving a combination problems required the properties to know. Okay, once you got all the properties and their use, that will be a very quick solving for the JEE. Clear? Okay, that's why your first lecture is of properties of combinations and next lecture is of main combinations. Okay, now next is C, selection of random objects out of the given objects. Now I just want you to make a list that in how many ways we can do this of selection of any four types of the fruits out of these fruits given. So can you make randomly? If I take apple, grape, banana, or grape, banana, orange, banana, orange, pear, watermelon, pear, watermelon, mango, watermelon, mango, or strawberry, or mango, strawberry, papaya, pineapple, then apple, banana, orange, then apple, pear, watermelon. So all the things are different, no? Okay. And we have a different data. So how we can do so? Means here nothing, no arrangement is required. Is there any kind of the question like you have to keep first plate with the filled with banana only, or second filled with the watermelon only? No, there is a no sequence matters. Just understand the concern, because see, whenever we are teaching it with that separations, but whenever you have a question, you have to judge whether it goes in permutations or combinations. Now we are selecting a random things which don't concern put any concerns over the arrangements. Clear? There is no arrangement, there is only selection. So we can say this is particularly a question of combinations. Clear? Why the combination is important? When selection and the selection is not easily possible. Grouping is important, but that is not easily possible. Then we have to select, go with the process called as combinations. Clear? Okay. Now so this process is mathematically proven with the combination. So I want to select a 4 fruits out of a 10 fruits. Very simple. So my n value is always bigger. You can't select a 5 things out of 2 things. Then you have to cut that 2 things into the parts and make it larger than 5 or equal to 5. Right? No? So this is same technique is over here. I have 10 fruits out of which I am selecting 4 with the common sense. N is 10 and 4 is R. And with the application of combinations formula, we got this answer, that are 210 ways to select any 3 kinds of fruits. So we can't write down no all 210 ways. Watermelon, banana, pear, then pear, strawberry or whatever. So we can't list out these things. That's why the combination is used. Clear? Okay. So this is a branch which deals with the passwords and many kinds of techniques. Advanced branch of mathematics it is, and it is completely calculation based. Okay, got your recall and reflection. First, to start with the before to start with the topic, you must know why we are studying that topic, because that can be your interview question for your after graduation. Okay, next is content we need to recall. Obviously, fundamental principle of counting, addition and multiplication, extreme important in combinations too. When we are using addition, whenever there is a condition of or. When we are using multiplication, whenever there is a condition of and. Okay. Next, factorials and properties of factorials that you know better. Then next one is linear permutations of alike and different objects. Sometimes it comes circular permutation. It is sometimes. And rank of word. You are remembering rank of word? Okay. So these things we need to recall before go with the content. And what are the today's content? Properties of combinations, Beggar's method, a very important method. If you have a question like rank of object in permutations, then you have a question in your question paper like Beggar's method, which is applicable with the Beggar's method, and it is a very easy method to apply. Instead, this method is having optional content. Either you can solve with multinomial so we have an optional thing for Beggar's method, that is a calculation pattern is known as multinomial theorem. But multinomial theorem increases your calculation. Okay. So in today's lecture, I am going to teach you the Beggar's method. But in the last lecture, we have some applications of combinations. In that, I am going to tell you the multinomial theorem. So it's up to you by which method you are solving these problems. But if you ask me, Beggar's method is most convenient method. Okay. Now, next one is combinations under some restrictions, and there are lots of restrictions for the combinations. That's why lots of formulas arises. Okay. So is it up to, it is completely up to you. If you know the technique and go with the technical solving, then you will get the same answer whatever I am giving with the formula. Okay. Next is practice questions. Combinations of alike objects is also very important. Now, before going to the properties of combinations, let me teach you first combinations, a very short, which is required. Okay. Now, anyone knows combinations? Already it was told to you with permutations only, because we have a difference of permutations and combinations. Combinations means the process is selection. So what is selection of kind? R out of n objects. Okay. So what is the formula? nCr is equal to n factorial upon r factorial into n minus r factorial. What you are observing? If you are observing, this is nothing but a permutation. This is a NPR. That green color part is NPR. Okay. So combination is made up with that formula also. We can say the alternative formula of combination is NPR upon R factorial. Both are true. Clear? Clear? Either you can go with the NPR divided by R factorial, or it is simply N factorial upon R factorial into N minus R factorial. Clear? Okay. Now I am going to tell you a very shortcut method to solve the combinations. We are always going to use the method. This one is useful method for us. We are not frequently using this method of permutation. Clear? Okay. Now, give me any certain value you want to do. That ma'am calculate this one. Like 51C2, 59C5, whatever you want. Anyone? The one who will first message, I'll take their numbers only. Don't take it in a thousands. Otherwise, it will be difficult for you to understand. See, always I am asking a question to you. Now I am giving chance you to ask me question. No one is putting any value. Should I take from my end only? Okay, let's take it. Fine. For example, I want to solve the 57C3. Okay, clear? Now, with the formula, what is the answer? I'm going to give this calculation by formula. And this is by shortcut. Okay. What is the calculation by formula? 57 factorial upon 3 factorial into 57 minus 3. How much it is? 54. Right? So we know that 57 into 56 into 55 into 54 factorial upon 3 into 2 into 1 into 54 factorial, and then it comes 3 to the 6. So how we can solve this one? Which one is divisible by this one is divisible by 1 to 3? No. right? No, and 2 is divisible, dividing this one, 2 to the 4. So it is 19 into 28 into 55. So what will be the answer? Twenty-nine two 260. Okay. So traditional method is clear. By formula method is clear. By formula method is clear because you need to give a stepwise calculation in your state board pattern examination. Clear? If this is understood, please proceed, reply in a chat box that yes ma'am or no ma'am. Repeat whatever you want to tell me. You can give. Okay. So this is by formula 57 factorial upon 3 factorial into 54 factorial. Now with the combination we can directly proceed how we are doing in a permutation. See how 57 and R value is, so you have to write down the 3 consecutive terms because R value is clear. If it is 57 C4, then what you are going to do? 57 into 56 into 55 into 54. Clear? Okay. Upon directly 3 factorial is 3 into 2. Upon directly 4 factorial is 4 into 3 into 2. Clear? And then you are going to solve. Clear how we are solving it with the quick method? Instead of writing all formulas and calculations, you can do this by this method. So which one is better to you for calculation? You can use that, but shortcut method is that clear that how much R value you have to take reverse order consecutive terms that much. Okay. If I have a 57 now, there is one more trick to solve this one. Now I am giving you the 57C3 and 57C54. Now it is not easy, no, to go with the 54 terms of 57. Getting my point? Okay. It is not easy that go with up to the 54. This is fine. This is, we can sort out that 57 into 56 into 55, just 3 terms divided by 3 factorial. Clear? Okay. But this is not done, no. 57 into up to 54 terms. Is it possible? No. So instead of that, we have an optional thing that just if this is coming very complicated, just do it 57C 57 minus 54. Clear? So how much it comes? 57C3, and then you can resolve like this: 57 into 56 into 55 upon 3 factorial. Clear? And then solve. Getting my point? How you are going to solve this one? Okay. Everyone ready for 19C2? Do it quickly with this method 19C2. Take it 19C2 for your calculations. $171. Okay. Ashrita done with the answer. Akshay done with the answer. 171. Please everyone check whether you are receiving this. You are taking same 19 into 17. Just 2 terms are required. Sorry, 19 into 18 upon 2. So 19 into 9. Yes, it is correct answer. Clear? Clear? You are finding combination that much easily possible to calculate with the shortcut trick. Okay. Now everyone try this one. 27C23 with this trick now. Minus trick I am telling you because both the values are very closer to each other. So in that case, we have to apply the alternative method. We know direct value of 24 is the direct value of 4 factorial. So you can directly cancel 24 also. 17550, very good. So 17550 is the answer. Clear? How to calculate combination is clear? Okay. So in words, what is the meaning of combination? It's simply out of 19 things, I am selecting 2 things. Out of 27 things, I am arranging, selecting 23 things. Clear? Arrangement is not the word, but selection is the proper word for the combination. Clear? Selection or grouping or team making, that is the applicable words of combinations. Clear? Have a smile on your face. Okay. The one who are smiling, for them it is clear. I know. Okay. Ashwin, please on your camera. Why you are putting off? And if you are not at your place, don't join the session. I have to be strict with many students now. Okay. Now, okay, so this is not a flashback. This is the next session's just an intro. Okay. Actually, we are just learning the properties of combinations today. So let's start. Okay. Next is properties of combination. Now see, nCr is a natural number. Obviously, there is a kinds of selection. So we can't say that it can be done in -2 ways. The number of ways can't be negative. Clear? So this is an integer, positive integer and positive natural number. Clear? Okay, so this is a very important thing. Whenever you are receiving your calculations of combination, sometimes if it is going in negative or in fractions, then you are absolutely wrong. Clear? Okay, so nCr is a natural number. This is the first property. Now, if you see, nc0 is equal with ncn is equal to with 1. Means what? See, just understand this. It's a very easy method to explain. If I am taking n is equal to 5, what values can this combination happens? Either 5c0 or with the 5c1 or with the 5c2 or with the 5c3 or with the 5c4 ways or with the 5c5 ways. This is clear? Out of 5 things, either I can select 0, 1, 2, 3, 4, 5. Is there 5c6 value possible? No. Out of 5 things, we can't select 6 things. Okay. So if you see the extremities, this is a very, very important property of combinations. The extremities are always equal, like these two are equal. These two are equal. And these two are equal. If you ever calculate this value, just calculate it very quickly. Tell me values, then you will get this. Calculate 5c0. Obviously, nc0 is 1. So 5c0 is 1. This is also 1. ncn is also 1. That I am going to tell you. 5c1 is 5. This is also 5. Calculate this one. 5c2 is 5 into 4. 1, 2. 2 2s are 4. So 5 2s are 10. So 10 will be the answer. See, check it in your notebook by calculations, but I am just giving the answer. So these both will have the answer same. Clear? This is an important property of combinations. The extremities always combines with the equal value. Clear? Okay. First and last are equal. Second and second last are equal. Likewise. Okay. So here this is an extreme important property because many times it reduces your calculations. Okay. Clear? NC0 and NC1. NCN. First and last value is always equal with 1. Clear? Okay. First and last value is always equal with 1, and similarly the second value and second last value is always equal with n. Okay. See what are the first and second result. This is always equal with 1 and this is always equal with n. We have the proper result for first and second values only. Okay. Clear? So hence the answer of 5C1 is you can write down 5. If I ask you the answer of 101 C1, what will be the answer? 1001 will be directly answer. No need to solve. Clear? Okay. So you can put directly this as a shortcut. Next is even the answer of 1 minute. Even the answer of 1000. Okay. 1001 C1000 is also same. Because it is having a difference of 1, no? So, both is having answer 1001. Clear? Next, NCR is equal with NCN minus R. That is told on this number line. Clear? First and extremities are always equal. Okay? Up to ABC property, there is doubt. First and extremes are equal. That is clear. So, tell me quickly, 10C2 will be equal with what? A quick question for you, not required more than 10C2 is equal with what? Quickly, by unmuting also you can tell the answer 10C2 quickly. Isn't it equal with 10C8? Okay. This is the property number C, which is again an extreme. You are solving. I am just asking you on number line. 10C2 is equal with 10C8. Clear? Okay. With the property now. Fine. Just have a look on this property. nCr. Okay. nCr, and this is R minus 1 actually. nCr and plus nCr minus 1 is equal to n plus 1 Cr. Now how this is working, see. We have to use this property many times. So I'm just taking it on a blank page. See, this is an extreme important property once again. nCr and nCr minus 1 means what? The first your observation must be that both is following same n. Okay. So if I take the 30C5 plus 30C6, sorry, 30C4. Instead of solving these two combinations and then adding, we can directly write down this equal with 31C5. Clear, completely cleared, completely cleared. Okay, okay. So compare properly because here we have n is equal to 30. R is a bigger number. So bigger number is 5 and R minus 1 is lesser number, which is 4. Clear? By this property, we can directly write down 31C5. Now my question for all is, what will be the answer? Quickly. 51C7 plus 51C8. Don't answer in terms of solving. Just answer in terms of combinations. C7, yes, but you have to compare R with the larger number, no? This is my R, just reversibly written over here. This is my R minus 1. So I know this is going to be happened. So it is 52C8. Now don't beat yourself what I am doing. Okay, got it? Clear? Clear? R is a bigger number and R minus 1 is obviously lesser number. So it will be 52C8. Okay, now next is NCX is equal to NCY. If we have a direct result like two combinations are equal, then X is equal to Y. Either X is equal to Y or X plus Y is equal to N. Both the things are true. This is an important. We are always ignoring the second case. Forget to take a second case. This will come by how the solving will arises. Then I'll explain. Okay. Then n times of n minus 1 cr minus 1 will be always equal with n minus r plus 1 and cr minus 1. This is an optional thing to remember. If you want to remember, you can. Otherwise, just forget it. Okay, clear? Okay. F property is optional for JEE students. If you want to remember, you can. Otherwise, skip it. Okay. Now, if n is an even, then the greatest value is arising at middle factorial. See, middle combinations are always showing the greatest value. First, I will take the odd case. What is the odd case? N, C, n plus 1 by 2. Just take it with the 10 only, means 5 only. If my n is 5, I have a 5 things to distribute or select. Okay, group. So, what will be the maximum value of combination? It will be 5C, 5 plus 1 by 2 and 5 minus 1 by 2. Clear? So what is the answer? Either it will be appearing on 5C, 5 plus 1, 6 by 2 is 3 and 5C 2. So no doubt when your value is n, it is maximum at 3 combinations. Our selection is 3 or 2. So see whether we are finding same or not. In the values 2 and 3, it is showing value 10. So it is maximum at these two stages. Clear? For odd numbers, we are receiving 2 maximum values. For even number, we are receiving 1 maximum value only. Clear? And that is exactly middle value. Clear? Okay. So what will be for even? It is directly equal with NC n by 2. So tell me what will be the maximum combination of maximum value of what will be the X? What will be the maximum value of this X? Maximum of 1002 CX will arise at 501, 1002 C 501. Clear? Okay. This is a property of G and F. Okay. Then this is again truly optional. NCR is n by r dot n minus 1 CR minus 1. If sometimes these two ratios are given. Many times in the JEE only these two ratios are given, like 5C3 upon we can say 4C2. Means this is the ratio of NCR upon NCR minus 1, no? So you can directly answer this by n by r. If you compare properly, it will be 5 by 3 only. Clear? Clear? If I shift this place to divide on the NCR side, it is n by r only. Clear? So this result works over the JEE problems if you got such kind of division. Instead of doing this so long process of calculations of combinations and then solving, you can directly answer n by r. Okay. Next is similarly NCR upon NCR minus 1 is n minus r plus 1 upon r. These are optional things. Whatever I am highlighting as in star, these are completely optional for you. If you go with the standard process of calculations, then also you will receive the same answer. Okay. Now, this is important. All the addition of combinations, 0, 1, 2, possible combinations like 5C0, 5C1, 5C2, 5C3, 5C4 and 5C5. If the all values are added, what will be the answer? 10 plus 10? 20. 20 plus 10, 30 plus 32. So we are getting same for 2 raised to 5. If I am adding 50 to 5C1, is we are getting 2 raised to power 5 answer? Yes, we are getting, no? 32 will be the proper answer. Got it? So with directly shortcut method, you can apply this one. Addition of all coefficients. This property is renamed as addition of all coefficients. Okay, coefficients that are called as the coefficients. Okay, addition of even combinations or odd combinations have the same answer, 2 raised to power n minus 1. Okay, this is the addition of even or odd particularly. Clear? Okay, and these are some results proved with that. This is an again optional things if you want to remember. These are completely optional. Clear? Okay, so whatever I am telling you, just try to understand. These are important property. I'm just adding them. A, B, C, D. Many questions are on this. E, G, H, K, L. Okay. At least you have to work upon 1, 2, 3, 4, 5, 6, 7, 8, 9 properties. 9 properties. Even this also very many times work. So just highlight this 10 property in your mind. At any cost, you have to remember this one. Clear? These 10 formulas of combinations. Okay. Now, this is done. Yes? Okay. Now, what is beggar? Who called as what you know as the synonym of beggar, or how you can explain the beggar? It is very anti-character. It's not like that, no? Beggars having nothing in their hand. Now, this is an, we can say, illusion. Beggars are more rich than us now. Okay. So, beggars is the one we can say that are always demanding for something from us. Okay. Clear? So, same thing is here. That technique is just a beggar's method. How this is derived now, see. In general, the number of ways of distributing alike objects must think, yeah, this is and must think that must be alike objects, otherwise this method will not be applicable. Clear? Okay. So what is, I have n data of alike objects distributed among the p objects. Okay, like I have a 5 coins and I want to distribute in the 3 beggars. Okay, I have 5 coins and I want to distribute in the 3 beggars. How we can do that? Meri marzi. 500, 050, 005, right? No, this happens in combinations. Getting my point? This is not an arrangement. Okay, so this method is called as a beggar's method. So directly you have to identify that the instead of going with the standard process, just remember this formula. Write down in your notebook. Write down. This is a very key shortcut for many examples of the JEE. Beggar's method. The distribution of n objects, the distribution of n objects among p groups or p kinds, among p kinds where all objects are similar or alike, where all objects are similar or alike, can be done in number of ways is equal to n plus p minus 1 c p minus 1. Write down that formula, n plus p minus 1 c p minus 1, and the method is known as beggars method. Clear? Now see how simple it is. With the standard process also I'm going to explain this. I have a 5 coins. Okay, distributed among the 3 students. What are the cases arising? What are the cases? Student S1, S2, S3. Okay, so either first one taken 5, remaining 2 are getting 0. Multiplied by 3. Such 3 cases will be arising. Right now? How? Because either I can give complete to S1 student 1 and remaining are getting 0, or I can completely give to S2 and remaining are getting 0, or I can give to S3 and remaining getting 0. These are 3 cases arises with the 500. Clear? What are other possibilities? 311. This is also triple. Either S1 will get 3 or S2 will get 3 or S3 will get 3. Clear? Okay. Then what is the next possibility? 2 to 1. Right now? So this is again multiplied by 3. Clear? Okay. So these are the possibilities. Is there any other possibility? I have only 5 coins and you have to think on this. I have 5 coins. I am distributing among the students. So how many number of ways are there doing so this task? This or this or this, or is applicable. So 3 plus 3, we can say 6 plus 3, 9. So there are 9 ways to do this task. Okay, clear? Now let's calculate with the beggars method. I have n objects, that is n is equal to 5, and p objects, that is p is equal to 3. What will be the answer? 5 plus 3 minus 1, c, 3 minus 1. So it is at minus 1. So it is 7, no? 7 c2. So it is equal with 7. It is equal with 7 into 6 upon 2. Sorry, and condition is applicable. I'm not getting same answer. Why this is so? We are missing with any case or what? Obviously, okay. So 2 to 1, 2 to 1, 2 to 1. This is also 3 ways. Okay, so maybe some cases are missed over here, but the thing is, into 6, obviously divided by 2. So 2 3s are 6. So this is 5 plus 3, 8, minus 1, 7, C2. Okay, we'll have this conclusion that this is an beggar method. Method is clear. Formula application is clear. Maybe there are some cases are missed over here. Okay. So this is about the beggars method. Like if you have n and p are not equal and that are alike objects. Obviously, if I am distributing 5 coins that are alike only. Clear? So we have to use this method in the alike objects only. Clear? Now with the beggars method, we have many kinds of combinations arises. Clear? Beggar method is creating many more new formulas. Now these formulas are totally optional for you. If you want to go with the solving conditions like how we are doing in permutations and then calculate, then also fine. If you are directly remembering the formula, this is also fine. Clear? So one by one I am clearing all the formulas. Number of ways of choosing R object out of n. Okay, fine. Different objects, if p particular things must be excluded. If there is a condition that we don't want to take a p things, then what will be the formula? n minus p cr. Obviously, if I have the example like I have the 50 batches and I don't want to distribute 5 batches, means obviously my 50 is reduced with the 5 number, no? So it is 50 minus 5, that will be particular n. Clear? Okay. So that is the same thing over here. Next case, number of ways of choosing r objects out of n different objects if p particular objects must be included. Like anyhow that certain things will be given to the certain candidates, okay, or certain objects like n minus p c r minus p, so that p things will not taken in the calculation, that are completely lost from n value also and r value also, because their selection, their mode of selection is already decided. Clear? Getting? So second method is this one. Third method, the total number of combinations of n different objects taken one or more at a time is directly equal with 2 raised to power n minus 1. Now this is completely optional. If you want to remember this formula, you can, otherwise you can skip it. Okay. The number of combinations of n identical objects taking at a time is 1. All are taken at a time. For example, I have 5 students and I want to select all 5 students. Obviously answer is 1, no? Only one method is there to select this one. Okay. So if you have a wording like this, you can directly apply it with the 1. The number of ways of selecting r objects out of n identical objects is n plus 1. This is important now. If out of p, q, r, s objects, p are alike to one kind, q are alike to second kind, r are alike to third kind, and s are is different, then we can say that total number of combinations is p plus 1, q plus 1, r plus 1 into 2 raised to power s minus 1. Now these are completely optional formulas. See the note. The list of alike objects can be extended further for the number of ways of which r objects can be selected from the group of n objects with the p identical. If I have a p identical objects, you can directly apply this formula only for p identical objects. If this comes in a questions, I'll explain. Okay, clear? These formulas are completely optional for learning, but whatever as in highlighted, Vegas method formula, n plus p minus 1 up into c p minus 1. Sorry, n plus p c minus 1 p minus 1 combination with p minus 1 is an important formula, and these are the properties which are important. Clear? Okay. So today's theory part is done. Now you will get this how to apply this with the formulas or examples. That is a very simple to solve. Now you need a break just before that. Yes, okay. So take a 10 minutes break. Then we'll start with the solving session. Okay, clear? Hello, am I audible? Let's start the solving part. Everyone, be on your places. Everyone on your camera. Mukeshwaran, Bhuvna, Netra, Bhuvna. Okay. See, the number of ways of giving 20 distinct oranges to the 3 children such that each children gets at least one orange is. What will be the answer you are thinking? The number of ways of giving 20 distinct oranges to the 3 children such that each child gets at least one orange is. What is the method applicable for this? If you read it clearly, it will be a beggars method, right? Okay. Now we have a 20 objects and 3 kinds to be distributed. Clear? So see how simple it is with the standard process of beggars method. What is the formula of beggars method? N plus P minus 1 combination with P minus 1. What is the formula for beggars method? I'm again revising N plus B minus 1 CP minus 1. Okay. This is the formula for Baker's method and we need to have the calculation of N is equal to what is the exact value of N and what is the exact value of P. Now, Acha, you are answering 231. Can you please tell me what exactly you have taken? If you see there are 20 distinct oranges and 3 children. Okay, fine, that is clear. But this is an again important case, no? Each child gets at least one orange. If this case was not given, then distribution can be, I can give 20, 0, 0. This can be one way also. Okay. But they are not telling like this. They are saying that at least one orange will be given to the each children. So, if we see there are 3 oranges already distributed among 3. Clear? Okay. So, n value is reduced to 17. Got it or not? 20 distinct oranges. Okay. Among 3 children. So, if child 1, child 2, child 3 is getting 1, 1, 1 and dash is reduced to 2, 17, 3 are already distributed. Getting my point? 3 are already distributed. So we have a new n, that is n dash is equal to we can say 17 and p value is equal to 3. Now you can apply the Beggars method and tell me the answer. Clear? So by Beggars method, solution new n value is equal to 17 and p is equal to 3. Therefore, using Beggars method, number of way is equal to n plus p minus 1 cp minus 1. So it is 17 plus 3 minus 1, C 3 minus 1. Calculate 19C2, you will get answer. Clear? Have a smile on your face. You are solving JEE 2023 question with the beggars method, and very quickly, in fact. $171, correct? So it is 19 into 18 divided by 2. So it is 19 into 9. It is equal with 171. Clear? So it is a numerical value question. So no negative markings will be applicable for this. But it is an easier one. Now the answer is 171. Okay? Clear? Now pay attention. Everything is done. Now I'm going to tell you the important thing. 1 minute. The bonus score is given for this question in the last examination, JEE 2023. The bonus is applicable for this question. Do you know bonus? The one, there is something wrong in the question and the students who attempt it, they are credited with the full marks for the question in JEE. So what is wrong in this question? Who will tell me? We are able to solve, but still there is something wrong. What is wrong? Anyone? We are able to calculate the answer with the beggars method. Still, this is a bonus question. Have a look. Okay, have a look. We are distributing. Is the oranges can be distinct? The one word only creating the matter. Distinct. There is a typing error of distinct. There are 20 distinct oranges. So student may get confused with the distinct word, and that's why they have credited the bonus marks for the question. Clear? Okay. Because distinct object combination is different and identical objects combination is different, and beggars method is obviously applicable for alike objects only. Clear? Okay. So that's why this is a bonus question. Clear? Okay. Now, next one. The number of triplets x plus y, x, y, z pair are distinct non-negative integers satisfying x plus y plus z is equal to 15. Okay. Now there is a distinct word, but it is for integer. Clear? So that is meaningful. Clear? Plus y plus z can be having distinct value. They want to tell that. Okay. Now there are 3 cases arises for this one. First thing, just forget about the distinct word. Just forget for time being. One calculation you can show that without a distinct word. I am telling you how many cases arises with one word only. If there is a without distinct condition, this case also can be acceptable, that I have the 15 addition is equal to 15 means 10, or we can say 16 plus 2 plus 2. Sorry, 15 addition is required, no? So 12. This is also acceptable case. Getting my point? Clear? Because here y and z are having equal value. But that is an acceptable case if there is no distinct word. Clear? So one word is changing everything. Clear? Okay. So without distinct, we can say first case. So what is if I take this as an without distinct? So very simple question. There are three divisions, x, y and z. So my p value is 3 and n is equal to total n value is 15 and p value is 3. Clear? Okay. So what is without distinct word permutation combination with the Vegas method? N plus p minus 1 c p minus 1 is equal with 15 plus 3 minus 1 c 3 minus 1, which is equal with 15, 16, 17, 18 minus 1, that is 17 c2. Clear? Okay, clear? This is clear? Now tell me answer of 17 c2. Done. What is the answer? Done? 136? Okay, fine. Now pay attention. But these are the when the opposite cases are asked anytime. When the opposite cases are asked, what you are going to do? Now the distinct non-negative integers are satisfying this relation. Means what? What are not required things? Means overall cases minus what will be the answer? X and y equal will be subtracted. Clear? Okay. Minus y and z equal will be subtracted. Clear? Or minus x and z equal will be subtracted. And one more thing is subtracted. X, y and z equal will be subtracted. Clear? With the one word distinct, how our calculations are changing. Clear or not? With the one word distinct, how our calculations are changing. Clear? Okay. Now, yes or no? So, see that overall cases you got at as 136. Now, we want these many counts from our answer to be subtracted. Now, there is only one case where x, y, z are equal. That is 5, 5, 5. Clear? So, last answer is also with us. Clear? Okay, there is only one case where 5, x is 5, y is 5 and z is 5. Then and then only their addition is 15, no? So, that is only one case. So, last answer is also with me. Now, if we say that if I found any two are equal, now see I am just taking the opposite one calculation only, that any two are equal. So that will be applicable 3 times. Yes or no? So our changed answer or changed pattern will be like this. 136 minus 3 times of any two equal minus 1. Getting or not? Clear? Whatever the count, if x and y are equal, same is applicable for y and z equal, same is applicable for x and z equal. Yes or no? So I'm taking any two will be equal. Now what is the case? Let's take it. X plus y plus z is equal to 15 implies that 2 times of x plus z is equal to 15. I am just replacing let y is equal to x. I'm just taking this one for our calculations. Okay. So what will be the answer of z? 15 minus 2x. Clear? Okay. So how many possible situations are there? Either x is equal to 0, 1, 2, 3, 4, 5, 6, 7. 7 twos are 14, right? So that is again n lower digit. But 8 is not applicable. 15 minus 16 is not applicable, no? So what are the possible values of x over here? Possible values of x are, x can be the set of 0, 1, 2, 3, 4, 5, 6 and 7. So I have total 7 values. Clear? 7 values are applicable over here. Getting or not? So total values of applicable x is 7. So it is totally equal with 136 minus 3 into 7 minus 1. So it is 136 minus 22. What will be the answer? Implies that it is equal with 136 minus 22. What will be answer? 114 is the final possibilities or number of ways to have x plus y plus z is equal to 15. Clear or not? Any two equal is clear. If any two cases are equal, then there are only 7 possibilities arising. X and y equal, that is 7 possibility. Y and z equal, that is 7 possibility. X and z equal, that is again 7 possibilities. So overall 21 possibilities. Clear? Minus x and y and z are equal, that is 1 possibility. So overall 22 will be subtracted from the overall count. Clear? Okay. So this is an answer. So 114 will be the, this is again a numerical pattern question. So answer for this is 114. Okay. Have a smile on your face. This is again an easiest calculations with the beggars method. Just there is an one needed thing is that in your mind it must be clicked in while attempting. You are going to attempt your JEE examination in 2025, right? No? In 23 you are doing 11th. In 24 you are doing 12th. So in 25 you have to remember that this is a question of beggars method. Okay. So this is the main concept for you all. Now the number of ways of distributing, I'll take this question last because this is a quite, we can say, time consuming question. This one, 1 upon 1 factorial 50 factorial means what? What is your observation by observing this question? JEE Mains 2023, if you see, we are solving all the current problems only. I have tried my best to keep you updated with the updated kinds of the calculations. Okay. So 50 plus 1, 51. 48 plus 3 is again 51. 46 plus 5 is again 51. So if I could adjust a 51 factorial in the numerator, every problem is having solution there. Clear? Okay. So it is nothing but what is a solving. Now I just given the hint of 51. Can you please tell me the answer directly? Hint is that every denominator ending with 51 factorial as a addition. This is an only applicable hint. Can you please solve? Everyone try to solve this question. Okay, I just received answer from Bhuna that 2 raised to power 50 upon 51 factorial. You are telling option D. Okay. Is there anyone else with the done with the calculation? It's a correct answer. Now let me give the hint. I appreciate answer given by Bhuvna. Now just look over here. Simple it is. The value of this is asked. So I am just making an adjustment of is equal to 51 factorial. And if I could multiply each term by 51 factorial, 1 factorial, 50 factorial, plus 51 factorial, 3 factorial into 48 factorial, plus 51 factorial, 5 factorial into 46 factorial, plus dot 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 51 factorial, 51 factorial. Okay, so what pattern you are observing? So it must be 0 factorial over here. So what pattern you are observing? 1 upon 51 factorial. Then what is the addition asked? 51C 50, 51C 48, right? No? So it is 51C 50 plus 51C 48 plus dot 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 51C 0. Clear? So all the even coefficients, even combinations addition is asked. So what is the answer of even combinations addition property? It is always equal with 2 raised to power n minus 1, right? So here it is equal with 1 upon 51 factorial into 2 raised to power 51 minus 1, that is 50. So correct answer is D. And even in the, if you see the denominator 51 factorial, 2 options are only there. So obviously answer will lying in either in B or D. Clear how simple it is? With the property it is simple, no? That is applicable case that you must apply your logic behind that. Okay. Then and then only you are able to solve. Okay. Clear? Should I proceed? Yes or no? Okay. See now. N plus 1 C6 plus N C6 is greater than N plus 2 C5 minus N C5. Then the values of N holding true, N greater than holding true. This is an again a property based question. What you will do? First thing, if you see, this is N plus 1 C6 plus N C6, but we don't have, see, if you observe this two, not any property is applicable, because our properties are changing the, showing the change in R value, not in a N value. Clear? Here N value is changed. Clear? Which is not applicable for time being. Okay? But we can say that if I put this minus on this side, that is NC5 is greater than N plus 2C5, and that if we see here the property is applicable. In between these two properties applicable. Okay? So what is that property is applicable? Which is the property applicable? nCr plus nCr minus 1 is equal to n plus 1 Cr. Clear? Okay. You will try with this property now. Hint is already provided to you. Please try this question. there is a change over question. There is a slight printing mistake. 1 minute. Here it is 4. Just note down. Then and then only it is possible with the proper calculations if you see. So take it 4. Now you will get the answer. So it is n plus 1 C4 and n C5 is greater than n plus 2 C5. So what is the answer? Sorry, here n C4. Property is applicable in between these two. At the first end, in between these two properties applicable. At the second end, in between these two, the same property is applicable. So you can try out this question with that property again. What is that property I am writing over here? nCr plus nCr minus 1 is equal to n plus 1 Cr. Just increase your n value with 1. So it is equal with n plus 1 C6 plus n plus 1 C5 is greater than so option B 9 is correct. Acha, I got the correct answer with the inequalities. See, everything we are doing with the positive numbers only, so no need to change the inequality. If you remember the inequality, we can say inequality rules by the chapter inequalities, we have seen in the linear inequality. So everything we are doing calculation based on the positive end only. Whatever we are transferring, multiplying, dividing, that is with the positive integral only. That's why no change in the inequality. Clear? Okay. If we could change divide with the negative inequality, then or multiplied with the negative inequality, we have to reverse the inequality. That is also you must keep in mind. Okay. Now, obviously combinations are producing positive integer. That's why inequality never changes. And if you could solve, you will produce that n is greater than 9 value. So they are asking the same. What holds true for the n greater than? Means everything is there. N greater than symbol. So only 9 will be the answer. Clear? Okay. Yes. Now, next question. Just try to understand this question. First thing, if you could read this question in JEE 2025, you will not get that this is a combination question. It's very difficult that this is a combination question to reach out to do this solution that this is a combination question or this is a particularly beggars method question. You will first try with the inequality chapter, then you will have any other suggestion with any other chapter. Okay. So see how I'm reading. If the total number of positive integral solutions is of 15 x1 plus x2 plus x3 is less than equal to 20. Basically, we are applying the Beggars method to the parts. Clear? Like oranges. What is oranges? Oranges is distributed in 3 parts. Or what is the numbers? XYZ integral solutions are distributed in 3 parts. So that addition will be 15. Clear? So basically, if you could judge this question by the same method, I want or we want by this question, we want addition x1 plus x2 plus x3 is equal to how much? Is equal to how much? 15 to 20 means a number which is greater than 15. So I'm taking a just above integer 16 to r value, and r can take the value 0, 1, 2, 3, 4, not 5, because 16 plus 4 is maximum reaching out with the, so 16 plus 0, 2, 16 plus 4. Clear or not? This is my first observation over this. Yes or no? R is clear? Solution set of R is clear. R is lying from 0 to 4. Okay. So already we have a 3 unique parts, and that is again having 4 integral options. Okay. So we have to use the last note in that properties. Okay. But I'll explain with the solving now. Next is 15 to 20 or is equal with the 20. So if we applied the Beggars method here, n value is nothing but 16 plus r, whatever is this side, that is our always n, and p is 3 parts. How many parts are there? 3. So p is 3. So what is the Beggars method? N plus p minus 1 c p minus 1. So it is 16 plus r. Okay, 16 plus r minus 1. Sorry, 16 plus r plus 3 minus 1 c 3 minus 1. This part is clear or not? The total number of positive integral solutions obtained by this. Now we are going to change the r values by timely options, but now this is 16, 17, 18, 19, 19 minus 1. So it is 18 plus r c 2. Up to this is clear? Okay. Now pay attention on the first, we can say that miscellaneous formulas which we are not. Okay. Just observe this formula. Read that note. Done? Now just understand in this example. I'm trying to explain here. Okay. The total number of positive integral solutions of 15 is less than x1 plus x2 plus x3 is less than equal to 20 is k, and the value of k upon 100 is calculated or it is asked. Okay. Now one more thing, that there is a change in the Beggars formula for this particular case. So what is this case? Now pay attention. Here that is only missing most of the time by students. Instead of the formula n plus p minus 1, the formula is changed at n minus 1 c p minus 1. How this is done? Now why this is done? We are excluding the some things from this. Now what is the exactly calculation? It is 16 plus r minus 1 c 3 minus 1. So answer will be 15 plus r c 2. Now everyone will ask me that, ma'am, why this n minus 1 upon p minus 1 or n minus 1 combination with p minus 1 is used. Now again, going towards the this formula, see the particular case. Okay. If p objects are excluded or included, we can say that here only I can explain. Or let's try out over here only. What is the excluded case over here? That's why we are not taking the p minus 1. The total number of positive integral solutions. Here there is a word positive. Whenever. That was I am trying to tell you in the first question as well. See, there are many cases arises over the number. So write down in your notebook that using Beggar's method, whatever I am writing on this slide, just write down in your notebook also. Using Beggar's method, for integral solutions, 4 different distributions arises. These are common distributions I am giving. 4 different distributions arises. First one, non-negative integral solutions. Non-negative integral solutions. For this, formula is different. Second one, positive integral solution. Okay. Third thing, non-negative distinct integral solutions. And fourth thing, positive distinct solutions. Any question can be made with this any 4 of the bits. Okay. So I am giving you indirectly the all 4 kinds of statement patterns which will be asked in JEE, and you will get to know that this is a question of Beggar's method. If you could find out this kind of statement pattern, you will clearly get that this is a question of Beggar's method. Clear? Okay. Now is there any difference? Okay, I'll first explain in Hindi. Everyone comfortable in Hindi? Okay. What is the meaning of this 4? Already I have explained in English. What is the meaning of this 4? I'm again explaining in English first. Non-negative integral solutions means that it is including 0. The solution can be 0. Means what? I want to distribute 20 coins. Means it can be 20, 0, 0 in 3 students. Okay. So it is acceptable case. 20 to the first one, 0 to the second one, and 0 to the third one. This is an acceptable case in the case 1 pattern. Clear? Okay. But whenever there is a positive integral solution, means 0 is not taken. Understood? Clear? For non-negative solutions, 0 is taken, and for positive integral solutions, 0 is not taken. This is a difference. Okay? Clear? Then third one is positive non-negative distinct integral solution, means that case like 18, 1, 1. I want to distribute 20 coins among 3 students. 18, 1, 1 is not acceptable. Distinct is required. 1, 1 is repeating, no? So no, never the similar number will be repeating. That kind of grouping. Clear? Okay. And the last one, positive integral means what? Similarity is excluded, and even 0 is also included. Clear? Okay. So these are the things. These are the 4 different. Now, for the one who are not understanding well in English, for them I am again repeating in Hindi. Okay. जब भी आपको ऐसा केस आएगा नॉन नेगेटिव इंटीग्रल सॉल्यूशन, उसके अंदर हम 0 को कभी भी कंसिडर नहीं करते. क्लियर? ओके सॉरी नॉन निगेटिव इंटीग्रल सॉल्यूशन मीन्स उसके अंदर जीरो जो है वो कैलकुलेट होगा. ओके सो दिस वन इज इंक्लूडिंग जीरो एंड सिमिलैरिटी. क्लियर? ओके पॉजिटिव इंटीग्रल सॉल्यूशन, इसमें सिमिलैरिटी तो चलेगा लेकिन जीरो नहीं चलेगा. सो इट इज एक्सक्लूडिंग जीरो एंड विथ सिमिलैरिटी excluding zero is only case, means similarity is okay with that positive integral solution. Clear? नॉन निगेटिव डिस्टिंक्ट इंटीग्रल सॉल्यूशंस के अंदर क्या है? एक्सक्लूडिंग सिमिलैरिटी बट इंक्लूडिंग जीरो. Excluding similarity but including zero is a non-negative integral distinct. Cases arises with the non-negative distinct integral solutions. Okay, and positive distinct integral solution means excluding zero and similarity both. Clear or not? 4 cases are clear. Okay. For example, I am giving the one more example to make you understand this. 1 minute. If I want a distribution 20 coins in 3 persons, what will be the answer? First case, कौन सा केस नहीं चलेगा वो मैं बता रही हूँ. एक्सक्लूडिंग जीरो इंक्लूडिंग जीरो सिमिलैरिटी मीन्स जीरो आया तो भी चलेगा. 20 0 0 दिस कैन बी डन इन केस 1. क्लियर? दिस इज अ एक्सेप्टेबल केस ऑफ केस 1. ओके देन नेक्स्ट वन excluding zero. Zero is not required and positive integer, so we can say 18 plus 1 1. This can be one of the option for case 2. Pattern of case 2 is like this. Okay, non-negative distinct integral solution. So non-negative distinct integral solution means what? We are taking zero. Fine, zero is fine, but similarity is not fine. So we can say that 18 plus 2 plus 0. 0 is acceptable, no, in this case. And the last one, excluding 0 and similarity both. So what will be the answer? I have to take that 17 plus 3, sorry, 17 plus 2 plus 1. Clear the meaning of all 4 cases? So when they are asking very particular case, you have to be particular with your formulas. Okay. So we have solved all kinds, these first 3 kinds of the solutions. 1 minute. Now directly we are reaching with the formulas. What formulas you are knowing already. Now we are not considering 0 in the case 2. So 1 minute, first one is. Okay, so what is the answer of first case? Directly as it is n plus p minus 1 c p minus 1. That is already applicable. Non-negative integral solution is asked. We have already done this type of questions. Okay. Now I am taking a distinct case of same. What is a distinct case? All cases minus similar cases. That you know. That we have done. X is equal to y cases are subtracted. Y is equal to z cases are subtracted. X is equal to z cases are subtracted. And x, y, z all x cases are also subtracted. Clear? So we are doing all cases minus similar cases. Okay. Now next one, what about this positive integral solutions means 0 is not taken. You can directly apply this formula whenever 0 is not the condition. N minus 1 C P minus 1. Clear? Okay. So in this, okay, so all cases of positive integral solutions with the word distinct positive integral solution cases. All cases of this minus similar cases. Clear all the four formulas based on only one. Likewise, we can create number of questions. X plus Y plus Z plus T is equal to 49. This is also one question. Clear? So number of questions will be created based on the integral summation or integral solutions. Clear? Just you have to clear with the wordings. Okay. Now in our particular question. Okay. The total number of positive integral solutions, no concern with the distinct or what. So I'm using the formation this one. N minus 1 C P minus 1. Clear? Okay. So what will be the answer? This one will be the 15 plus C, 15 plus R C2. Now what value R is taken 0 to 4. So we can write down it is equal with summation of R is running from 0 to 4. 15 plus R C2. So which is equal with 15 C2 plus 15 plus 1. So it is 16 C2 plus 17 C2 . Clear? You are able to solve this with the property. You are able to solve this with the property. Solve and tell me the answer. Same property is applicable. nCr plus nCr minus 1 is equal to n plus 1 Cr. To use this with the property, do the one more thing that 15C3 is adjusted. See, I am doing the adjustment of 15C2. So I am just subtracting it also. See here 15C3 added and subtracted. Now you will get the property. What will be the answer of these two? 16C3 plus 16C2 plus 18C2 plus 19C2 minus 15C3. Okay, what will be the answer of these two? 17C3. Just increase your n with the one value, and 17C3 plus 18C2 plus 19C2 minus 15C3. So what will be the answer of these two? Next two, 17. I just missed 17C2. Okay. So do it and tell me the final answer. Now only calculation part is remained. Just these two. It will be 18C2. 18C3 plus 18C2 plus 19C2 minus 15C3. Then next we have the answer between these two. The same property can be applicable. 18C3 and 18C2 is converting to, I am writing over here, 19C2 C3 minus 15C3. So finally we can use this property in between these two. Last one, it is nothing but 20C3 minus 15C3. Clear? Do the subtraction of values and tell me the final value. 1370. One three seven zero is correct answer. 20 into 19 into 18. 20 into 19 into 18 divided by 6. 1140. Okay. And 15 into 14 into 13 divided by 2. 1365. 23. Okay. Yes, 685 is the correct answer. Right. So you are getting 6850 as a difference. What is the answer we are receiving? Should I do it for your understanding? Okay, I'll be solving. So here it is 20 into 19 into 18, 3 terms upon 6, minus 15 into 14 into 13 upon 6. So it will be 685's answer is correct. Clear? Okay. But there is a one more thing. The integral, then the value of k by 100 is 6.85 is answer. Clear? 6.85. Actually, that's this kind of numerical value question. So it is based on the mostly perfect integer. There may be an bonus question to this also. We don't know exactly, but 685 is the correct answer. Clear? Okay. So that is the process of solving. Cleared? Now we are left out with the one question. Try that question at home, or otherwise just with the initials only and the start of lecture only, just remind me about this question. Okay. Now everyone, you are clear with the Vegas method and properties of combinations, how we are going to apply the properties of combinations. That was our today content. Now before this lecture getting end, just quickly check whether class assessment is open to you or not. Properties of combinations, Vegas method, and some restrictions over combinations we have seen today. And that was a very truly important question, a lecture for JEE's point of view. Okay.